Alright, this is chapter 5, which deals with exponential and log functions, the beginning of it. So before we just jump straight into the material like 5.1, this is like a review of the properties of exponentials and logs that you're supposed to understand and know. So just a review. Pause it if you need to write these down. If I have the same base to different powers or to the same power multiplied together, I just add the two powers together. So this would be like if I had 5 squared times 5 to the 4th. Right, that equals 5 to the 6th. Okay, and then a to the m over a to the n, we subtract when there's division. Multiply, we add the powers. Dividing, we subtract the powers. So this would be like 5 to the 9th divided by 5 to the 8th equals 5 to the 1st. Alright, 8 minus 9. 9 minus 8, that is 5. 9 minus 8 is 1. 5 to the 1st is just 5. Alright, and then powers to powers, products to powers. We're multiplying two things together and then raising them to a product. This is one of the few times we're allowed to skip the order of operations. So an order of operations says multiply these first, then take them to the power of m. Well, if I had 2 times 3 squared, think about it for a second. 2 times 3 is 6. 6 squared is 36. Was that not the same as 2 squared times 3 squared? 4 times 9. So either way I get 36. Okay, so this thing does work. Alright, and then this says that if they're a fraction raised to a power, we can raise the numerator and denominator to that power. Alright, and this is the powers to powers property. This is when we have, like up here, we had 5 squared times 5 to the 4th, and we got 5 to the 6th. If we have just 5 squared to the 4th, alright, notice we're missing that second 5, that second base. Now we have 5 to the 2 times 4 is what this is saying, which is 5 to the 8th. Okay, so if that second base is not there, we don't add, we multiply. Alright, and then the negative exponent rule. A to the negative m is 1 over a to the positive n. So this is true for all negative exponents. So I call it the negative exponent rule, or property. It's better to call these properties so people don't think we're playing some kind of game with them. These are things that we found to be true, not we made up to be true. Alright, so use those properties of exponents to simplify these things. So a 5 to the 6 over 5 to the 4th, that's division with the same base. So for part A, we've got 5 to the 6 minus 4, which equals 5 squared, which equals 25. Okay. Part B, we've got y squared over y to the 5th. That's y to the 2 minus 5, which equals y to the negative 3. Okay. Now, we never want to leave negative exponents, so we use this negative exponent property here at the end to change that to a positive exponent. So that'll be 1 over y cubed. Now, notice there's also, you could have done this problem this way, y squared over y to the 5th. This is like y times y. This is like y times y times y times y. Remember what an exponent means, is just repeated multiplication. Alright, and now cancel 1 up top for every 1 down below. We're left with 1 up top and then 3 y's on the bottom. Okay, so you can use the subtraction rule, or you can just think about it, what it means for those things to be one on top of the other. Alright, for C we got 3xy cubed. So for C we got 3xy, all of that being cubed. Alright, so we use the products to powers rule, meaning that we cube all of these things. We cube x, we cube y, and we cube the 3. And then 3 cubed, if you can evaluate it, evaluate it. 3 cubed is 27. And then we don't know what x and y are, so we just leave them x cubed, y cubed. Alright, and then D, we have a quotient, meaning a division, and then being raised to the 4th power. So for D, we just use this rule right here. A division raised to a power, raise each part to that power. So we're going to get y to the 4th over z to the 4th. Alright, and we can't do anything because we don't know what y and z are. And then for part E, I got 3 raised to this expression power, 15 minus 2m. And that's being multiplied by 3 to the 2m power. Alright, now we do have the same base. Alright, there's a 3 here, there's a 3 here, so that's when we add the exponents. So that's 3 to the 15 minus 2m plus 2m. Alright, these wipe each other out, and we just get 3 to the 15th. Okay, now normally if it's a number to a power, I would ask you to evaluate this, like give me a number, but as you'll see on your calculator, some of these things are huge. 3 to the 15th, your answer is returned, well, this one's not that huge, not as huge as I thought it was going to be. So we would write that down. Let's see, that would be 14,348,907. 14,348,907. I thought it was going to return scientific notation. So if it does, just write the scientific notation out. But we'll get to that in just a little bit. But if it's a number to a power, then write the number out. Okay. If it's variables, then obviously we can't do anything with them because we don't know what they are. But anytime you have a number, if you can get a single number out as your answer, then do it. Alright, like we're going to get here on B and D. Alright, more powers of powers. So A, we've got x to the 4th to the 5th. Okay. The reason why I'm practicing so many of these is just because people forget when they multiply and when they add. Alright, this is the situation when we multiply, when that base only shows up one time, and it's in a parentheses being raised to another power. So this is x to the 20th. Alright, 2 to the 3rd to the 5th. Yeah, we could say that that's 2 to the 15th. But notice also 2 cubed is in a parentheses. We can do that. That's 8 to the 5th. Alright, and then just 8 to the 5th power. Again, get your calculator out. 8 to the 5th is 32,768. Alright, now notice if I would have done 3 times 5 is 15 and did 2 to the 15th power, I would get the same thing. Okay, so they are identical. It's just this one we can do in order of operations, so I chose to do it that way. Alright, part C, it's a pretty nasty one. It's a power on a base already, and then multiplied by another base to a different power, all raised to a power. But just like before, it's like this thing, x squared, we're going to raise it to the 5th, and it's being multiplied by y cubed, and we're raising it to the 5th. Alright, powers to powers, just like we did up here. If it's just a single base to a power twice, then we multiply. Single base to a power twice, we multiply. So x to the 10th, y to the 15th. Alright, and then for D, we got 2 to the 3 to the 2. Alright, now, what we have to understand is this is 2 to this power 4. So we have to deal with the exponent first. So this is 2 to the 9th power. And then go to your calculator. 2 to the 9th is 512. Right. If you did this as 2 cubed first and then the square, I mean if you did, let me just write, this is not the same as 2 cubed first and then squared, which is 8 squared, which is 64. Okay, obviously 64 is not equal to 512, so they're not equal. Okay, but I just want you to understand that when you see this, you don't do this first and then do this square. You do this first. Remember, we do the innermost exponent. We got to figure out what this exponent is before we can raise this base to it. Alright, now look at your calculator. If I did 2 raised to the 3 raised to the 2, what does my calculator return? 64. Okay, it's doing it left to right. We got to understand that we need to do this exponent first. Alright, we need to understand that this is 2 raised to the parentheses 3 squared. So we get the correct numbers here. Okay, the exponent is 3 squared. We need to figure out what 3 squared is before we raise 2 to it. Alright, so this is one where you have to be extremely careful, because your calculator, the way you type it in there, just the way it's written, will not return what this exactly is supposed to be. Alright, more practice with negative exponents, just because they give people fits as well. Remember, negative exponent means that it goes down to the denominator. So this is going to go down. Alright, this is going to stay up because it's not a negative exponent. It's a negative number, but the exponent's not negative. And this doesn't have a negative exponent, so it'll stay up. Alright, so we're going to get negative 2 and a y. They stay up top. And then the x to the negative 2 goes down to the bottom and becomes x to the positive 2. Okay, so negative exponents go down, positive exponents do not. Alright, times over here. This goes down and this goes down. Alright, the 5 does not. It's not being raised to a negative exponent. So the 5 stays up. The x squared goes down and becomes positive. The y negative 3 goes down and becomes y to the positive 3. Alright, and then to simplify, just multiply straight across the top. We get negative 10y. Straight across the bottom, x squared times x squared is x to the 4th. And then there's a y cubed down there. Alright, and then last thing, cancel one of these y's with one down below. And we get negative 10 over x to the 4th times y squared. Alright, for b, I've got an 8xy to the negative 2. I got a 2x to the 4th y to the negative 6. Now, it's also the case that if a negative exponent is in the denominator, that it goes up to the numerator. So this y to the negative 6 is going to come up where the y to the negative 2 was. That y to the negative 2 is going to go down where the y to the negative 6 was. They want to be positive. Alright, we want positive exponents, so we have to move these negative exponents around. Alright, the 8 and the x are not being raised to a negative power. They're not in a parentheses like it is here. Okay, so we're going to leave the 8x and the 2x to the 4th alone, only messing with the negative exponents. We're going to move this y to the negative 6 up and call it y to the positive 6th. We're going to move this y to the negative 2 power down and call that y to the positive 2. Okay, and then the 2 and the x to the 4th don't change places. Alright, 2 will go into 8 4 times, so that's going to be up top. Because 8 is bigger than 2, the 4 will be up top. Alright, this is like an x to the 1st and x to the 4th, so 1x is going to cancel with one of these and leave 3, so I'll have an x cubed down below. Alright, and then 2 of these y's are going to cancel out with 2 of these y's and leave me 4 up top. Alright, and now that takes care of everything. So there's our answer to B. Alright, for part C, we got 4 to the 0, x cubed, y to the negative 2, all to the negative 3. So 4 to the 0, x to the cubed, y to the negative 3. to the negative 2 all to the negative 3. Alright, now the first thing I'm going to do when I see something like this, note over here to the side, 4 to the 0 equals 1. Alright, this is equal to 1. Alright, so there's no point in having it in there. 1 times x cubed is x cubed, so we're just going to not write it. So this is the same thing as x cubed times y to the negative 2 all to the negative 3. Alright, so we've got a product of powers, so we're going to do x cubed to the negative 3 times parentheses y to the negative 2 to the negative 3. And remember, when we only had that base written one time, we multiply. So this is x to the negative 9th times a negative times a negative is a y to the positive 6th. Alright, now remember, positive exponents stay up, negative exponents go down. So we end up with y to the 6th over x to the 9th. There's our answer. Alright, now, again, what do? Do I add powers or do I multiply powers? Well, we have the same base. So same base means we add the exponents. So this is x to the 1/3 plus 3/4. Alright, to add those fractional exponents, we need common denominators. Alright, 1/3 is the same as 4/12. 3/4 is the same as 9/12. So we end up with x to the 13/12 power. Okay? So there's A. B. Y to the 1/2 divided by y to the 2/5. That equals y to the 1/2. There's division of the same base, so we subtract the exponents. So this means we need common denominators again. LCD here is 10, so this is 5/10 minus 4/10. So that ends up being y to the 1/10. Alright, and then C, powers to powers. So for C, I got c to the 1/3 raised to the 3/4. So this means c to the 1/3 times 3/4. 3's cancel, and you end up with c to the 1/4 power. Okay. Alright, so notice again, there's two x's being multiplied, so that's when I add the exponents. Down here, there's just a single variable with two exponents inside the parentheses, or around the parentheses. That's when I multiply. Alright, so you got to know when to do what between these two things. Alright, and then scientific notation, that makes use of positive and negative exponents. If you ever do this on your calculator, notice it gives you this E notation. That's your calculator's version of scientific notation. But I want you to see that if I write 6.2256 times, oops, let me turn it on, 6.2256 times 10 to the 4th, which is what scientific notation actually is. Alright, we get this number, 62256. Okay, remember the times 10 to the 4th moves this decimal point over 4 places. Okay, and we get that number back. But this is your calculator's way of saying times 10 to the 4th. So what you need to understand is times 10 to the 4th is what this E4 means. Okay. Same thing with this. E negative 4 means times 10 to the negative 4th. Alright, so this would mean negative 4 means that decimal point is actually 4 places. 1, 2, 3, 4 back that way. And we need these filler zeros. So I get the 1, 2, 3 zeros before the 2, 3, 5. Positive 4 mean it goes the other way. And we end up with this. Alright, so that's scientific notation. And then here's some problems in scientific notation. And notice I just went ahead and put these in on the calculator. 7.93 times 10 to the 5th back-to-back parentheses means times this other number in scientific notation. And notice it returns a number in scientific notation. Okay, so that means my answer is, don't write it like this, right? 3.6426429 times 10 to the negative 1. That's what this number means. Right, same thing here, 1.749506903 times 10 to the 12th. Right, the scientific notation comes in, scientific notation comes out, and we write our answers in scientific notation. Don't use the e to the 12th stuff. Transform that to times 10 to the 12th. Alright, so this is the review that you need to get ready for 5.1. I'll start the 5.1 notes in the next video, but you got to understand these properties of exponents to be able to do the 5.1 notes.